It is time for our final optimization. What we're going to do is cache these query results when we don't need to fetch them from the database fresh. So what I did is seed up the database with 1 million records, and it's a SQLite database. So it's still not going to be as slow as a production setup, because my requests before were like 25 milliseconds, which is just not real life, because, I don't have to run out to a server somewhere in another state or country, and I can just go right to this computer. So if we do something like toggle amount, look at that. That 196 milliseconds is the round trip. That's good. That's slow. A lot of websites you go to, like, let's go to GitHub Livewire's page, and let's let's do something. I wonder if sort oldest. That's a whole new query, a whole new request. I'm going to hover over something like, okay, I hovered over something, and okay, we got 147 milliseconds. I'm going to keep hovering, and hopefully, yeah, okay. So, there was a 650, but most of these are about 140, a couple 190, 132, yeah. So that's more realistic, real life request speeds. You can get even faster than that, but that's real life. What we were dealing with isn't necessarily real life. 25 milliseconds is just not reality. So I wanted to crank up as much as I could the database to get something that's a little bit more real life, especially when you're working with a large data set. So I'm toggling these, and now I'm getting, okay, so that was an anomaly, 84 milliseconds, 205, 215. I'm going to add as much sorting as I can, and I'm going to add also another constraint to the query. Okay, so there we go, 318 milliseconds. Awesome. So when I toggle this right now, look at this. 322 milliseconds. That's great, because that is very real life. And now look at our beautiful Node.js data table. We're toggling advanced search, and it's taking 1/3 of a second. That's not good. So the other things need to take as long as they take. Anything else that deals with the data, of course, you need to do the full request. You would do the same in a Vue.js app. Whenever you change some constraint, you need to refetch the data. So one thing I'll say is, a lot of times when I see slow Livewire apps, or slow apps in general, a lot of it's the database's fault. It's so often the database's fault. But in a case like this, let's just presume that we can't make it any faster than that. 300 is kind of reasonable. But we've used Livewire for other things on this page, like this, and even showing a modal. So now that modal just feels slow. Everything just feels a little bit slow and laggy, and that's not what we want. So I'm going to address the elephant in the room. How do we speed up this Livewire component for the actions that don't require interacting with the database? So we're going to use caching. And this is very straightforward. This is not anything fancy with Livewire. We're just going to use Laravel caching, and we're going to cache the database query and use the cached version when we don't want to use the non-cached version. So here's the thing with caching. Here's my disclaimer. You may get confused if you try to do caching like this. There's what's that? Like the two hardest things in computer science. It's like naming things, and it's like off by one, cache invalidation, and naming things, something like that. Cache invalidation, and that's even just a fancy. We're just dealing with caches in general, and knowing when to invalidate them or bust them is very mind-bending at times. Like even when I was writing this, I ran into a weird edge case, and I was like, this shouldn't be cached. Why is it cached? But that's just how it goes. So there's two basic approaches to caching. Let me get the code here. So this is the get rows property, that computed property, where we return all the paginated rows, the results. We could cache this, and various places throughout the component, we could bust that cache. We could invalidate the cache so that the next time we get here, it won't have a cache, and it'll have to get it fresh from the database. That's okay, and that's an okay solution, but you end up having to bust the cache all over the place. So I think we're going to use the opposite approach and opt into caching. And so I think what we're going to do is always cache the results and only use the cache results explicitly when we want to. And the places that I want to is really this create method. When I hit this button, I don't want it to take 300 milliseconds. There's no reason it has to go back to the database for that. When I hit this edit, and I also want to do the toggle advanced search. So the first thing that we're going to do is let's open up that advanced search thing. Where is that? So advanced search, we're saying toggle show filters. What I want to do is actually call a method called toggle show filters rather than using that action, because it's going to be easier for us to hook into this. So let's break this out into a method now, and we're going to say show filters is equal to not show filters. Okay, great. So let's make sure that works. We refresh and it works, but it's fast again because we lost all of our good sorting and searching. And okay, so now we're back to feeling slow. Click, wait, click, wait, click, wait. Okay. So what are we going to do? I think we should just start with a new trait. Let's start with a trait called with caching. Yeah, I think that's what we're going to do. Is it with cached rows? With caching? With cached rows. Yeah, let's do that. And then let's take our with sorting. We'll duplicate it. We'll call this with cached rows. Okay. Paste this in. And now we're good to go. Okay, back to the component. And I'll open with cached rows trait in a separate split pane here. Let's import that. Okay, and now we can do some fun caching stuff. So like any trait that I've been adding here, I want to keep as much code, as much cache related code out of here as possible. So let's take a look at where we're going to actually use caching. So here's our get rows property. That's a computed accessor for rows. And we want to optionally cache what's inside here. So if you've ever seen Laravel's caching, there's like cache put, where you can put like a key and then a value. And then there's cache get, where you can get that key or a default value from here. Okay, that's how caching works. There's also a fantastic method called cache remember, which I love because it allows you to specify a key and some time to expire, like a minute. And then you can, in a callback, you can return some value. Basically, this is going to make up for lots of temporary variables. The way this works is if you did something like this, if there is no cache for that key, it's going to use the callback. Otherwise, it's going to use that cached key. So we're going to create our own kind of similar approach. So let's do something like this. This cache, let's just say cache rows. We'll just say cache. Maybe we should be using remember or something, but I don't know. But yeah, we're going to call this cache. Okay. So now this is going to be our little hook. We're going to add a method called cache. And let's see, we could probably bump this up a little bit. All right, we have this method called cache that accepts a callback. So here's where we're going to do cache stuff. And actually, before we do this, why don't we keep declaring the public API? So this is what we're going to do here. We're going to opt into this cache, and we're going to defer to the trait to decide whether or not to use the cached rows or to re-get the rows out of the database. Okay. So in something like toggle show filters, we'll do something like this, use cached rows. Okay. And now this will opt into caching, and we can add this to create and edit as well. We'll add that in a bit. So let's add a method called use cached rows. Okay. And now we can do our business. We're going to have a property called use cache that's set to false initially. And then we'll set this to true. Use cache equals true. Okay. So when use cached rows is called, the property use cache gets set to true. And then when the code gets down to this cache callback, inside here, we'll have a conditional that says if this use cache, then we can actually return the cache. Otherwise, we can return the callback and its value, which this is just kind of pseudocode. We'll implement this in a second. But okay, making sure that looks good. So use cache rows, use cache. I think we're looking pretty good. Now let's do this logic. So if use cache, then we want to get out of cache, we want to cache get by some key, which I'll talk about in a second. So let's call this cached. So here's why I have to do this. We can't just return cache get, because let's say that we want to use cache, but we haven't actually cached anything yet. In that case, we would be returning null, and that's not what we want to do. So we need another, what do we need? We need another thing here. I guess we need to say There's probably a more elegant way to do this, but I'm just going to say if cached, then return cached, okay? So if you're using cache and cache exists, then return cache. I suppose maybe a better way to do this would be, let's do this. This might be a little bit more expressive. Remove a temporary variable. We'll say cache has. If cache has for that key, then return cache get for that key, okay? I think that's a little bit better. And even, you know what? Let's drop this right in here. If use cache and cache has key, then return cache get key, okay? And now we don't want to just return the callback. We want to actually store the callback, and we need to cache the callback or cache the result of it. So cache put key, we'll get to the key again. Okay, and now return results. Okay, the reason that we're doing this is here's our approach. It's kind of an inverted approach. We're going to always cache the results. We're going to keep this queue of cached result in this key. And then when we opt into it, we'll use the latest one because that's whatever we cache put. So it's actually kind of backwards, but this is way more sane than doing the opposite, where you're only where you would do something like the inverse. Everywhere else you would say skip cache, but then you run into all these problems when you accidentally don't skip the cache, and then you're trying to do your pagination or something and you keep getting the same results over and over and over. So I think this is a much better way to do it. We're just going to kind of secretly, sneakily always keep the results in the cache. And then when we want to use the cached rows, we're going to use them, okay? So the key, here's the thing we have to do. This key can be anything. So what do we want it to be? If it's just something like rows, this is going to apply to every table in your entire app. So you could have 5 different users using the same thing and their rows are going to interact with each other. And you know what? Maybe that's what you want. It's possible that that's what you want. No, that's definitely not what you want. No. That is not what you want. Forget I said anything like that. But this, honestly, this is one of those things that's incredibly powerful. You could use caching to share data between different components throughout your application. You could scope it to a user by doing something like auth ID. But what we're going to do is something really crude. We're going to make the cache key the current component ID. So every Livewire component has an ID. You can actually see it. Now let's do this in the console. If we say livewire.first.id, oh, that's not going to work. .instance.id. Okay, this is the instance ID. If I refresh the page and we get it again, it's different. So every Livewire component has a unique ID for its lifecycle. It's not the component name, because that would be across all page loads. This is just going to be the component ID as it lives on the page. You could make it the component name if you wanted it to not be the component instance, but every instance of that component. So you decide the cache key that you want to use. We're going to use the ID right now. And maybe to make this a little bit more discoverable, we're going to say ID, and we'll even say use the component. I don't know. It's kind of implied. And then here we'll say cache key. Okay. And now I imagine that I'm kind of curious to know right now if we could just return cache put. So I'm just going to satisfy my own curiosity and let's see what it returns. Returns a Boolean, unfortunately. Let's see what set does. I was hoping that there would be something that allows you to set, to do a set, but also return the result. So I don't know if there's like a clever way. I mean, we could return like a tap of callback and then get the result in there and cache the result. But honestly, I don't know. Is it worth it? I'm not sure if it's worth it. Tap's kind of an interesting one. I don't always like using it, but let's do it, whatever. Okay, let's put this in here. We can name this result and then cache put. Oh, but then we have to use cache key to get it out of there. No, see, tap's worse now. Now it's worse. Now it's uglier. Okay, back to where we were. This is not that bad. This is the entirety of the trait. It's not that bad. Okay, So we have used cache rows. So check this out. And I think we don't even need to refresh. Well, so let's get everything going here. We're going to get a bunch of constraints, a bunch of query constraints. Okay. And now I'm okay, so this is fast right now because it's using caching. And if I toggle something like this, it's slow. So let's take a look at the network speeds. So here we have almost 300 milliseconds, and then when we toggle, please hide, we have 52 milliseconds, much less. When we hit edit to show this modal, we're back to 300 milliseconds, and we don't need to do that. So let's do this. Use cached rows for create and edit. Now, granted, I want to let you know and remind you that you could use Alpine.js for this toggle, and you would avoid this. But I think for edit and create, I would rather still do what we're doing right now. And this is a really valuable lesson on caching in general in Livewire. So now if we hit edit, we're 54 milliseconds. Check that out. 53, 44. We've massively cut down on the response times. We hit new and it's very fast feeling. So this is great. Now everything feels fast and snappy, but the things that need to be slow, they still are slow because they have to be. So that's it. That is the holy grail of data tables in Livewire, is making the things fast that should be fast and keeping the things slow that, have to be slow. And that's where we're at. I don't know what else to say. I think we've done pretty well for ourselves, folks. Oh, this feels good. I feel like we've done data tables justice. I feel like if you have some thing that you need to do in a data table, I have now shown you how to do it, and I feel good about that. So thank you for watching, and keep on keeping on. I'll be seeing you.